To inspect a node to see how it is actually constructed, we can select a node and then go up here, and we're going to have options to actually, the first one here is to actually create a new custom node with our own code. And the second one is actually to inspect the code of the current node that is selected. If I push that button, I will have the node block editor that is appearing here. It is basically two tabs, one that contain the code tab using the node markup language. To have more information about the node markup language, visit the API documentation. There is a specific section that is dedicated strictly to that, allowing you to create your own plugs, create your own input and output, and basically reproduce exactly what these nodes that have actually been generated automatically, and using that same markup language to create your own. So when you're creating a node, it involves first specifying how this node will be constructed using the markup language, and the second one will probably be to have a function, a custom function that is actually associated to it. What we're going to do is we are going to actually convert our PBR shader to use a custom node. To do this, let's get back to our navigator and select the PBR shader. Since the beginning of this tutorial, we have been dealing with a node tree that was actually coming from a script. This time we're going to create our own custom shader node, but for a shader. We are basically going to convert this PBR shader to be a node, one for the vertex shader and one for the fragment shader. First, we're going to create a duplicate of that shader. For that, we're going to go under library, select the shader directory, select our shader, and now simply click the duplicate button. We basically now have two PBR shader available to us. From our code editor, let's select our PBR0, which is going to be our the one that we will edit our custom node. The first thing that we have to do is to actually create a node, to enable nodes so we can have access to create a node tree. And I'm going to jump to the node editor. The first step will be to create our entry point for both our vertex and fragment shader. To do this, simply go on the tree, push spacebar, and under program, we have basically the two entry point, one for our vertex shader, and repeat the process for fragment shader. With that in place, we're going to switch to the end of that shader, which will need an exit point. So to create an exit point for our vertex shader, we're going to go on output and select GL position. For our fragment shader, we're going to repeat the same process, and this time we're going to select frag data. The next step will be to actually create our two custom node. For that, we're going to go under the toolbar here and click the create new custom node. Automatically the node block editor is opening up, and for this we're going to call it PBR vertex. And I am not going to add code right now. We will first create both our vertex and fragment, and then we're going to go back filling the code for both. I'm going to click build, which will force this new node to be created. And now if I open up with my spacebar and I go at the bottom, I will have a new catalog that is created with my PBR vertex node. I'm going to double click on it, and I have it created and placed on my node grid. I'm going to repeat the same process, but this time I'm going to call it PBR fragment, and I'm simply going to build to create the new node. As you might have noticed, the node block editor is very similar to the actual code editor. We are having a split that is allowing us to search and specify the name of the node and the catalog, and we have basically two tabs that allow us to switch between code and function. Since now my PBR fragment node is actually built, I'm going to repeat the process and add it to my node tree. Under the catalog, I am going to have access to my PBR fragment. With that in place, the first thing that I'm going to do is now to start editing my vertex node block code. For doing this, I simply have to select it and then click the edit button. I'm going to start by filling in the definition of that node, how it will be created. So using the node markup language, I am first going to specify, since now I am using a shader, I will have to specify the type of the output that my node will have. After that, this little tag here is telling me that I'm going to have an output that it's called position, and the type of that output would be a vector4. And then I'm going to specify that there's going to be an assignment, and then I'm going to call my PBR vertex function, which is an actual GLSL function. And finally, I'm going to specify that this node will have a link that can be connected to another node. So if you notice, it's basically a mix between markup language and basically some actual code. So what exactly the node generator will compile is basically it's going to replace this markup tags with actual plugs or output or input and so on, or links. So you have to basically visualize that to create your own custom node, you're going to have to specify the code that will be generated in the background, and how do you want this node to interact, what kind of parameters, input and output, that will be connected to that specific node. If I build, automatically I can see that my node have now changed. I am having a position output that I can then connect to my GL position. The only thing that we need to do at this point is to specify really the PBR vertex function that will return us that vector for that position. To do that, we're going to go under function. And now I'm actually going to need to copy and paste my actual vertex shader, my original vertex shader from my PBR. I'm going to close that temporary, go back to my PBR shader, ensure that vertex shader is selected, and I'm going to copy the whole vertex shader and then go back to my node and paste it under function. And now I'm going to want to do a few modifications, since my texture coordinate attribute and varying basically need to be passed along to the fragment shader. I'm going to have to remove them, and I'm going to replace the exact same operation with a node. I'm going to remove my attribute, I'm going to remove my varying, and I'm going to remove the calculation, the assignment of that attribute to my varying. Now, the next thing that I have to do is to actually change my main function to return a vector4, and the name of that function will be now called PBR vertex. Instead of calculating and assigning the GL position inside this function, I am actually going to create a variable called my position, and the function will actually return that position back from my node. My position, I am going to compile the node, and now I am going to go replace the attribute and varying assignment that I remove. For that, I'm going to create a varying that is going to be a vector2, because we're dealing with texture coordinate. Let's say that the precision is medium, and we are going to go search an attribute which is our texture coordinate. And now what we are trying to do is to assign to our varying the texture coordinate. So for that, I am going to need to create a assign node that is going to basically create my assignment just like if I was doing it in code. So I am going to go in math and assign, and now I'm going to reproduce the exact code by saying that let's invert them, make it more clear. I am going to have my varying, which is basically my destination, and I'm going to have my text coord attribute that is going to be my source. So now my varying is basically assigned to the attribute is now basically assigned to the varying. I am going to connect the node to dictate the shader execution. And finally, I am going to connect the position to the position. And as you can see here, my vertex shader node can now be compiled. If I go check the source code, basically I have nodes that generate me these variable for me, and then I have my PBR vertex function that is actually now assigning my GL position. And now since we have our varying, we're going to be able to drag and drop it to nodes from our fragment shader to actually pass the actual texture coordinate to our fragment shader. First thing I'm going to do, I am going to create the node block by editing it, and I am going to paste this little piece of code here, which is very similar to the one that we did for the vertex shader. I am going to this time specify my fragment output, which is going to be a vector4, a color, and it's going to be named fragment, and the name of my function this time will be PBR fragment. And for that, I will need to pass to that function basically the same thing that we were sending over by direct call to our texture. So the first plug that I'm going to pass is the base color, which is going to be identified as a color. Second one is going to be the normal, the roughness, and metallic. And finally, create a link that is going to bridge to another node. I'm going to compile, and now we're going to need to go search the fragment shader code. If I close my editor, I can see that now my node looks very, very different as the way I left it off. I have now plugs that allow me to either select or specify the base color, the normal, roughness, and metallic values. Now what I'm going to do is I'm actually going to create a function using the original code from my PBR fragment shader. If I select it, ensure that fragment is selected, and Control A, Control C, I go back to my node editor, select my new PBR fragment node block, and the edit function. I am going to paste the full code in here, and similar as I did for the vertex shader, I am going to want to start replacing variable. Basically, we have our samplers 0, 1, 2, and 3 that are that can basically either come from a user specified value or from a sampler, a texture. They are now parameters. As we can see here, our base color is now a color. Our normal is also now a color. Roughness is now a float. Metallic is also a float. So I am going to basically comment these guys out, since they can either be filled in manually or by connecting them with another node. My varying also is unused at this point, so I am also going to comment it. And if I drag all the way down, I am now going to modify my main function to actually return a vector4, and I'm going to call it just the same way I did it here, PBR fragment. And I'm going to start specifying the exact same parameter from the plug that I specify. I'm going to have a vector4 for my base color, a vector4 for my normal, float for roughness, float for metallic. And this is the parameters that I'm going to actually type in here. Vector4 base color, vector4 normal, and float metallic, roughness, and finally float metallic. Now I do not need those anymore. I am going to connect it, and I am simply going to assign, since my albedo was supposed to be a vector3 here, for a question of convenience, I'm simply going to convert it as albedo equal to base color RGB to convert it back. Similar as my normal here, I do not need actually to have my normal that is now pulled from a texture. I am simply going to comment that and replace here the pull from my texture with my normal X, Y, and Z. The last thing that I have to do now is to basically return that my function is sending a vector 4 at the end instead of assigning the frag color, since our frag color is actually a node. So all I'm going to do is do a simple replace. I'm going to now return instead of assigning it to the fragment color, I'm going to actually return that color, and I am going to rebuild my node with the updated code. With that set up, close the node block editor, and I am going to now connect my function here and connect my frag data. And now I have my shader that actually compiled based on the node markup language script that I have created. And now instead of pulling from texture, I am actually able to specify those values. If we go back here in our scene and we select our checker PBR and simply replace, instead of using our original one, now use our node tree that we have created. And now, as you can see, I am now able to specify the color dynamically, manually, of each and every of these parameters. Now, if we want to repeat the operation to actually select texture, we're going to need to add and connect new nodes to actually pull from the texture that we have, such as our base color, normal, roughness, and metallic. We can now have an alternate method between a user-based variable or direct data coming from a texture.